Welcome to a lesson with Dr. Powell. Let's look at this recursive formula for a sequence. And let's also suppose that the beginning of the sequence, maybe a sub 0 is equal to 4. Now we've already seen what the limit is going to be. We know it's going to be increasing up to 4 from the little picture that we were looking at earlier. Now there's a question, how do we do this algebraically? For one thing, I just told you what those intercepts were with this line. It should be pretty clear. How can you find those intercepts? Well, basically, you're just finding the intersection of this guy and that line, and you can do that algebraically. And then from this picture, you know that a sub 0 is, in here, and you're increasing up to that point. So you always go. So the idea is you always go horizontally to the line y equals x, and then to the curve, vertically to the curve, horizontally to the line, vertically to the curve. So horizontally to line, and then vertically to curve is kind of the idea as we make those stair steps. And we're heading toward there. Now, there's another way we could think about this. What if we just think about taking a limit of both sides? Now, if we did that, see what happens. Now, so a sub n plus 1 is the same sequence as a sub n. It's just one further in the sequence. And this is a continuous operation, so the limit can pop inside. So you're just one further in the sequence, but you're still going to the same thing. So taking the limit of this, if the limit exists, is the same thing as this, since this is really the same sequence. It's just, what I'm doing is saying a sub n plus 1 and a sub n. These are the same sequence. This is just one further in the sequence, but it still should be going to the same place. So what we could do is when we take a limit of everything, a limit of both sides, we know that a sub n plus 1 and a sub n both go to L. So then we have an equation. L is equal to square root of AL plus 15. So this is similar to thinking of this as like intersecting with y equals x in this, and then you replace your y value here with y equals x. You're doing a substitution there to find out where they intersect. And that actually, it's the exact same computation here, right? But we've seen it with limits. Knowing this goes to L and that goes to L, we get this. Then we can solve. And then when we solve, we can square both sides. L squared is equal to 8L plus 15. Subtract over and look at this quadratic equation. Is that equal to 0? Factor it, and we get L minus 3 and L minus 5. So, and so then we know L is the intersection points are 3 and 5, and that's how we can figure out what that limit was. Notice that assuming the limit exists from the monotone convergence theorem, it works out as well. As we were increasing and bounded right there. And so, yeah, it works out great. So we end up knowing that the limit indeed is 5. We just kind of work through the details of this algebra right here. But that's pretty much it. Thanks for watching.